I'm videotaping in class.
She's just taking selfies.
Oh, yep, totally. That's what I do.
You're taking selfies on your laptop.
All class. All day, every day.
Should I give you points back?
No,
I'm gonna kill someone.
I'm not going to ask for my points back. It was.
Yeah, I did. It's not you. It's a couple people in particular.
This is the easiest web.
Oh god. Although one of them has been scratched off the list.
What?
I said I want to kill somebody, and he said, "Oh, I feel nervous." Sitting next to you, I said, "No, don't worry. It's a couple people in particular. One of them has been scratched off the list."
No, I don't know yet.
Laughing about things.
All right.
I didn't do the homework.
Oh, speaking of which, yeah, let's take him down for content guidelines.
Look at me being right. Everybody should worship me. I am a genius.
I talked to my mom. Yeah.
Wait,
Yeah.
we all have chairs.
Yes.
Anyway, I gotta count this. 1, 2, 3, 4, 5, 6.
This is the cool kids table.
Do you see any cool kids around here right now? In this entire school?
I'm cold.
Except for Dr. Dong. Dr. Dong's the only cool kid.
I'm falling off a
There are
chair
now
at relativistic
27
speed.
people.
Dr. Dong, you're basically the only cool kid in this.
Nothing. Alright,
God,
so
Ben, shut up.
what it moves into my template at relativistic speed.
Don't steal my words. I copyrighted them.
If you're falling off a cliff at relativistic speeds, how long does it take for Katie Berger to expel you?
Instantaneously. The speed of light.
Wait, see, with Katie Berger, it's like with quantum entanglement. Like you could be on the other side of the universe, and if you break a rule, she'll expel you instantly.
Keep in mind that the camera is live right now.
That's great.
Yeah, you're welcome. That was
a good
When she breaks physics just to expel.
I still don't know who Katie Berger is. I've never seen her. I've never seen a picture of her.
She spoke at convocation. Oh wait, you were like
Pay
dying.
attention to convocation.
Wait, why were you dying?
Because I don't sleep, Micah.
Sleeping is good. You should.
Replace it with coffee. Just replace it with coffee. That's all we need to
You
do.
know that technically doesn't work?
Placebo. At least let it placebo. Just let it placebo.
You know the best time to drink coffee is A-Pod?
I mean, it is a stimulant, but like all stimulants, the effect
Not A-Pod,
eventually wears off, and you have to increase your dosage.
Like during
Exactly.
Just increase.
I did really well except for that last question.
I'm very scared.
In what reference frame?
In what reference frame?
In the reference frame of my understanding, or in the reference frame of my students?
A little bit about how I grade quizzes. You know, it's interesting. I actually tried. I was like, let me try and grade these differently. Let me give more. Let me grade on the same system I grade the exams and the system I use. Anyway, I tried it out, and it didn't work at all. It gave completely the wrong grades. It made no sense. Basically, everyone got between 93 and 98. Didn't make any sense. Once in straight A, you came to the wrong school. Could have stayed home. Just saying.
Hey, at least it's almost
You wanted easy A's, then why did you leave your school, right? So,
Because I wanted easier A.
no, but the main thing was, the grades weren't reflecting things properly, and I realized what it was because I was combining two different systems, and it worked right, I looked at different places and anyway, don't need to go into all that. I switched back to the older system because they gave the grades that made sense to me. So it's no longer everyone has a 98. The way it works is you get 1 of 4 grades, you get that, which means correct, you get that, which means you missed something, usually small, such as a minor calculation error, or units or something like that. You get that, which is pronounced meh, and it means you got something, but it's something fairly important. And then you have a slash through it, which means it's wrong. Okay? This corresponds to full credit 75%, 50%, 0% respectively. And the reason that makes sense is because normally what happens is you try on a problem, and even though you don't really get anywhere, you get some points for it anyway, right? Well, what happens was I've already done those already, because the minimum score you can get on the quiz is a 55. So basically, you've already got your pity points. Okay? The only points from here are your real points. So if you try to fail, then you get a slash, and that's because you've already got the 55 like pity points and everything. So you had to do something actually real to get beyond that. That was the mistake I was making. I was mixing two systems, but still giving that 55-point boost, and that was what was making the grades too high. So having worked that out, so that's why it's like it seems very strict. But it's because you didn't really get anywhere. If you didn't really get anywhere, you don't need any more points. You don't deserve any more points. No points. So, overall, we put it, okay, if you didn't, the average is 83. Standard deviation is 10, which is normal. The deviation is 10, which is normal for me when I'm used to, but I think a little on the large side for a lot of high school level classes. So that means it might be a bit more distribution than maybe you're used to. That's normal for college courses at least. So anyway, the main thing is if you are not happy with your score or the way the quiz went, you need to decide what is going to happen differently for the next quiz, which currently looks like it might be next Thursday. So, which is a week from today. So, right, the question is, okay, well, if I wasn't happy with this, then what am I going to change in the following week so that the next quiz is not like this one? If you are happy with what you're doing, then maybe everything's fine. That's cool. Okay. So I will leave that part up to you. You are welcome to come talk to me, outside of class about either study techniques or about the material. And honestly, I'm better with material than study techniques, but I'll do my best with study techniques. Right? I can tell you what I have seen, but what I have found is that it seems to be very much an individual endeavor. People have methods that work for them. And probably your best bet is you need to try something different. Well, try something different, and then see if that works any better. Right? That's the best thing. Alrighty, let me get these back. I'll then, if I have to ask your name, don't be offended. You can take it. You can touch it if you want. It won't hurt. I mean, except when you're old.
If I don't take the quiz, does that mean that I never formally took the grade and it will not? I got the first two correct.
No, I'm nervous.
We all probably got. You got a level 1. No, you definitely got a C.
What kind of coffee did you get?
And
what? The vanilla one.
Yeah.
They counted the last one wrong. Oh, it's not C.
Yeah, I knew this. I figured this out. No, it's not C. Okay, here's the thing. Think about it. The reference frame with the proper time. And the reference frame with proper time. The reference frame with proper time and the reference frame with proper distance aren't the same, so then the speed's never actually seen. So yeah, there you go. Yeah.
Wait, so it's like the answer
Yeah. Huh?
The answer I got was 1 over the square root of square plus 1. I hate my life. I could have gotten a better grade, except I screwed up 5.
I tried doing this. I spent like 20 minutes staring at this, like thinking how that's possible.
Say that again?
To the possibility that it wasn't possible.
Isn't the speed of light the same in each reference frame?
Yes, but there's never when it's going the speed of light in a reference frame. We just assumed it was because you guys calculated it with 2 different reference frames.
It wasn't in 2 different reference frames. It was in the same reference frame.
No, it wasn't.
It had to be.
No, it doesn't.
No, they weren't. It doesn't have to.
Okay, yes, it does.
No, it doesn't.
Because it says the proper distance.
Yeah.
The proper distance is when it's in the 2 stars.
Yeah.
The proper time is going inside the spaceship.
They're not in the same reference frame.
Oh, because proper time.
I think
And then the time is 1 year, the proper time is no. Spaceship reference.
No, the proper time would be in the
It doesn't,
spaceship, right?
yes, and the proper distance is from the stars.
Got
No, 2
you.
different reference frames.
God, dang it. Is it undefined then? Because if you do the conversion, it equals...
Well, I have 1 over the
It
square
equals
root of
25.
c squared plus 1, and he says that's meh, so I don't know what that means.
I also have 90.
I don't like this grading system.
Got everything right except for this one.
What did you get?
Like 70 something.
I got 70.6, yeah.
71,
78.8.
How do you get 60.6? I get 71.3. How does that work?
This is something that
You might have gone
you
up.
don't get.
You got to
take
make
all the
on
steps
this.
back as soon as we're done here. Okay? I never let kids keep cuts. So I'm gonna take these back. You may take notes as needed. The primary notes to take are not about the questions themselves. You know what I mean? Because you're not gonna have the exact question again. What you need to figure out is what did I do wrong? What do I need to make sure to do in the future, etc. Right? Those are the things that are relevant, right? But anyway, whatever notes you're going to take to yourself, you got to take them on something separate, okay? All right, so number one, if it starts with what is the laser speed, there's only one answer. C.
Yeah.
Laser is light.
Okay, so
We all knew that laser is light.
Yeah.
Right? I think we got that. You would have got that. Okay. If not, lasers are the speed of light. Okay, good. Now we know. All right, so the clock that Jimbo and John both frame, this one generally went fine. The main question is which of these frames, there's the clock. Which of the frames is the proper time is the question. If you think about it, the two events clearly are Jimbo throws it and John catches it. In the clock's reference frame, it looks like they're the ones moving, right? And so which of these reference frames is the proper time? The clocks, right? If the events are throwing and catching, it's the clock where throwing and catching happen in the same place. Therefore, this is the one with the proper time. So the clock is the proper time. Therefore, the one that they give you is the not proper time, right? And the gamma factor. Okay, some of you, I'm not going to do this in class. Some of you need to learn how to do arithmetic. I actually agree. It's actually not that easy. You may have had a bad middle school that did not teach you this properly, or jumped to calculators too early, or something like that. But at the same time, I really can't teach it in class. You know what I mean? And I think you know how to do it. You just need to practice it. But if you messed up some of these things, some of the gamma calculations, you need to go and fix it. And there are quite a few you did, and you just need to go make sure you can calculate gamma. It's not hard, and I know you know how to do it. You just need a little reminder, or wait, it's not like that. Oh, right, okay. So I can help you with that outside of class, but you need to be able to do the arithmetic. Also, some of you guys have a weird obsession with decimals. I already told you decimals are bad for exact calculations. Fractions are much easier.
because C split.
Number three,
Both of them are
I
squared.
don't
That's the
know
problem.
whoever taught you that the square root of 0.51 is fully reduced. That is not a reduced form, right? Yeah. The reduced form would be root 51 over 10. Right? That is the properly reduced form. Square root of a decimal is not a reduced form. So those are just basic things. Maybe you did work there before. It's easily fixed. It's just arithmetic or algebra, right? And it's honestly not that easy, but you have learned it before. You just need to remember it. So please, for the future, make sure you remember it, right? The gamma calculation. So the gamma for 26, for example, should look like 1 over the square root of 1 minus. And don't write 0.6 here. That's hard to work with. Instead, convert 0.6 to a fraction. That's not hard to do, right? 0.6 is 6 over 10, which you can reduce immediately to 3 over 5. And always reduce your fractions right away to make your calculations easier later. So it's really 3/5 c that we're looking at. So it's 3/5 c on d squared over c squared, which is 1 over the square root of 1 minus. So 3/5 squared is 9 over 25, and then the c's cancel. Then that's the same as 25 over 25 minus 9 over 25, which is 1 over the square root of 16 over 25, which is 1 over 4/5, which is 5 over 4.
Yeah, that's what I did. Okay, I get it.
This is stuff that we did. People honestly problems with it. I am not making fun of you. I understand it's been a while since you've done it. You may have had a bad
Cancel out this.
preparation
Yep.
in elementary,
Exactly what I did. No,
but at the same time, you know how to do it, right? So if you had trouble with it on the test, you need to go practice. What I would do is just do gamma 1 times 2 times x and 1 when you went through the fractions, right? And just work them all out. You can check this out once you're unsure of the answer. And just make sure you can do it right. If you can get those right, you're doing okay. You will, of course, have to do other math ones and do more practice on the homework and stuff that you can do. But you got to be able to do this. This is basic math, right? The fact that you have a calculator does not mean that you do not need to know how to do this. Okay? All right. So anyway, moving on. So once you have that, then the gamma is 5/4. The answer, therefore, is straightforward. Therefore, 10 equals 5/4 times the proper time. So the proper time, therefore, must be 8.
Messed up the math again. Got it wrong.
People did pretty well on units. I was glad
Messed
to
up
see
the
that.
math.
Okay.
Just a
For
little.
number 3,
So.
it's a meter 6. So the proper length, by definition, is
I
a
just didn't
meter.
read it.
Yeah.
Therefore, the gamma factor for 0.7 is root 51/10. I do a lot of relativity, so I know the gammas pretty well. You're not expected to have to do that in your head. It's fine. Oh, by the way, gamma goes this way. You guys keep drawing it the wrong way, right? Gamma is the fish swimming down, not swimming up, right?
Have I been doing it wrong?
The other one is lowercase l. You gotta make sure you can tell them apart. No, I mean, we actually use lowercase l in physics too, so like, you actually have to make sure you know them
Technically,
apart.
you're allowed to.
Okay, so given this, length contraction equals the proper length divided by gamma, which should give you, did I get this upside down? I got this upside down. Which is, sorry, of course it goes that way. Where was I? Which should give you the reciprocal of that.
It helps my teacher prepared me the use of calculator.
Okay, good. As you guys mentioned, level 1 generally went well. You did points, you did it usually because you switched up the proper time, or you got it to the unit mistake.
Everything I got wrong except for this one. I
Okay,
did
number 4 is a bit trickier.
That's
The main thing is what it gives you 0.8c, gamma for 0.8c is 5/3. It gives you 80 beats per minute. The main thing to realize is that the unit beats per minute is not a time, right? It's 80 beats over 1 minute, right? That's not units of time, that's units of 1 over time. Beats can be kind of ignored for the moment. Well, you can do it this way. So if you want to make it as a time, you have to get time on the top, right? That makes it a time. So that's easily done. 1 minute, 80 beats, right? What that means is that's minutes per beat. What that tells you is that is that the time for 1 beat is 1/80th of a minute. You could of course switch to seconds if you want to, but there's really no need, right? But the important thing is that you change it to a time. Okay? Once you change it to a time, obviously you can run time dilation on. In this problem, clearly the people playing the band are the ones who are stationary between each beat of the band, right? So the people who are the band are the proper time, which means that this is your proper time, right? And so now you do
No, I totally
time
did
dilation
wrong
on
on
it.
literally every
So
problem.
the time from
Well, I know what I did
the
wrong on it. I don't think it answer.
or the earth.
No, on this one?
Time for
I
the
know what I
earth
did wrong on this one.
is
Yeah, we
1/80th times 5/3.
On this one. First off, I did the math wrong.
16, so it's 1/48 minutes
Cancel out the
is
C's again.
the time between 2 beats
Too
on the
early.
earth. Then you want an answer in tempo, so to get back to beats per minute, you flip it upside down again, and you answer. So this is how many minutes per beat. You want an answer in beats per minute, you take the reciprocal again, and you get 48 beats per minute.
Or you can rewind it.
Yes, sir.
Set up 80 beats per
The way I did it varied a little bit. I, instead of putting in the 10 at a time, treated the beats per minute as a length. Because I thought logically you have, it's very much like philosophy of
That
over
worked?
time. And it worked.
Okay, the reason it worked was accidental. I do not recommend you go that direction. Here's why. The reason it worked is because if you treat it as a length, you have length contraction as a 1 over gamma, whereas time dilation is gamma, right? So you end up taking the reciprocal, which is exactly what you needed to do to get the right answer. But that's coincidental. 1 over minutes is not a length, right? It should not be treated as a length. In other things, it can screw, in a more complicated problem, it can screw things up. So I'm glad you got the right answer. There's a certain insight to see that, because length and time, if you have that kind of reciprocal relationship, but that's not going to work in every problem.
Okay.
Okay, good. Number 5. Article 4 to the towel, what's the reference?
Hitchhiker's Guide.
Thank you. Hitchhiker's Guide to the Galaxy. Shame on you. Shame on you.
Oh.
Very good creation point. Thank you.
What is Hitchhiker's Guide to the Galaxy?
Oh my god.
Shame.
So, reference to where's the famous prophet?
Oh, that's Beowulf.
Good job, Beowulf. The Hrothgar and the Hrothgarettes are named up. I always thought that'd be a great name for a match. So you are before looking at the towel. Here's the thing, it doesn't tell you how long the towel is, right? But which of them see the towel at its proper length? Neither.
Yeah.
Right? They're both moving relative to the towel, so either of them will have the proper length here. If you try to do it with a single length contraction, then you're not going to get the right answer.
Is it neither or neither?
Depends on what continent you're on. But on this continent, neither is preferred. Yep. Doesn't matter if you say neither though.
So what you would have to do is the length of the towel would actually be the proper length, correct?
The length of the towel in its own reference frame is the proper length. But Ford will not see the proper length. Ford is traveling back. Velocity of Ford is going 0.5 c relative to the towel. The relevant gamma that goes along with that is 3 over root 2. You can work that out. So that means he is going to see a length. The length that Ford sees is going to be the proper length over gamma, which is going to be root 2 over 3 times the proper length. Right? I did the math quickly, like you can see. I just did a length contraction where I don't know what the proper length is. Some people actually plugged in a number at random, which works. Because if I don't tell you a number, no. Some of the time, if I don't tell you a number, that's because it could be any number. That's this case. That doesn't always work like that.
Oh, for gamma of Ford, I got 2 over root 2.
Say it again?
For gamma of Ford, I got 2 over root 2.
Yeah, 0.4.
No, of Ford. Like
The gamma for 4, you got what?
2 over root 3.
For Ford.
For number 4, you mean?
Yeah.
Yeah, no, for number 5. For 4. You had 3 over root 2. I got 2
Yes.
over root 3.
Thank you. Sorry.
Whoops.
Thank you. Keep on doing things like that. I'm not going to sleep anymore.
That's right.
Sleep's
Sleep's
overrated.
overrated.
Make mistakes, and then you tell me about them, and it's all we're all good. And if you don't tell me about them, we're not all good. So tell me about them. I'm still fine either way. So that's Ford's length. Thank you for correcting me. Now, the length of Arthur's reference frame, whatever it is, we know that Ford sees it twice as long as Arthur sees it, right? Meaning that a lot of people have this up at this point. Ford sees it twice as long as Arthur sees it. Therefore, Arthur sees it how long? Root 3 over 4. Okay, right? A lot of people went the wrong way at this point. Okay, multiplying by 2 instead of dividing by 2. Please be careful. Those things are simple, but they plagued you since 3rd grade and they're not going anywhere. That's actually tricky, guys. So stop and make sure you're going the right direction on this. Okay? Okay, so Arthur sees it as root 3 over 4 times the proper length. Okay? Which you know is going to be the proper length divided by Arthur's gamma. Right? So, therefore, from this equation, you can say, oh, well, then, if you set these equal and cancel the proper length, you get 1 over gamma is root 3 over 4. This just needs to be solved. 1 over gamma is the square root of 1 minus b squared over c squared equals root 3 over 4. Square both sides, you get 1 minus b squared over c squared equals 3 over 16. Rearrange and you get b squared over c squared equals 1 minus 3 over 16, which is 13 over 16. Therefore, b equals root 13 over 4c.
It feels bad to add that last
Easy
step.
step.
Right? It feels bad. I messed up on the very last
you
step.
You didn't know how to simplify the square root of 16.
So, how do you do number 6?
Look, I messed this up so bad. I just forgot
So
the
a lot of people have messed up also in
root.
this area. That's just a matter of practicing your arithmetic.
It's so sad.
Right? So work on it. If you have questions, by all means ask me your question.
Oh, also, I got exactly 1 question on this quiz completely right.
So square root of 13 is outside of that
Rip.
4.
Yeah, I feel.
Okay, number 6. Number 6 never gets old.
Oh,
So, do you see what I mean? Do you see what I mean about
You have the right answer, Paul.
Try to do an idea of what I'm talking about all threes.
No,
Try to make them not too
I totally
much
realized how I messed it up and how I
not
could
too
have
much.
fixed it. It's frustrating.
Not so much as crazy like how I put column by column, but more to like make it hard for you to figure out what's going on. Right? In this one, you're like, wait a minute. If the distance is 1 light year and it takes 1 year to get there, how fast are you going?
C.
And you should have, and if you marked C as your answer, you should have at least said, but I know that can't be right, or something like that. You would have gotten me more points, but actually on an exam it would. On my exam, the partial credit systems work differently because I grade the test differently. I'll talk about that later. But
Why?
To write down things that you know
I
are
would have gotten
solutions work differently.
better.
Okay, well let's talk about how to actually do it. The reason it works is because it sounds like it's giving you 2 numbers and it comes out. Well, those 2 numbers are in
different reference
frames, so you can't just pull it together and get C, right? The proper distance between the stars have to be in the frame of the stars.
Stars, 'cause
so
they're
the
not
length of the
moving.
frame of the stars is 1 light year. Remember we write light year like that? Okay? Whereas the station measures the time, that means the time in the, star station. Wow. The time in the spaceship's reference frame is going to be 1 year. Different reference frames. So if you're going to make a statement about velocity, you have to be able to get the information in the same reference frame. That's not hard to do. You have 2 options which will give you the same answer. You can either find the time in the star's reference frame or find the distance, the distance in the spaceship reference frame. Which do you prefer? We'll do distance in space reference frame. Sure, why not? So the distance in the spaceship's reference frame, since this is clearly the proper, it's even told you this is the proper distance, right? Yeah. So therefore this one must be 1 light year divided by gamma. I don't know what gamma is, but I don't know the velocities, right? Okay. From here, the second, if I didn't understand your work, I don't give you credit for it. Okay? I have nothing against partial credit, but there's only so much time I'm going to spend on a problem. For some of you, this may mean it is actually a matter of luck as to whether or not I can figure out what you're doing. If you prefer not to leave things up to chance, make sure your work is neat. And that's just how it works. Does that give an advantage to people who are neat? Yes, and it should. All right. So now that I have them in the same reference frame, I can figure out what the velocity is by taking distance over time. As long as they're in the same reference frame, that's always valid. But if these are different reference frames, you can't see them. Okay, so it's just a matter of saying, well, I know what the velocity is. The distance is 1 light year over gamma. The time is 1 year. You should be able to get the years to cancel out, right?
Yeah.
And so you end up with C over gamma equals V. Okay, we're not done yet, of course, because we don't know what gamma is. But gamma is in terms of V. So let's simplify this, make it V over C. We'll put the C on that side, equals 1 over gamma. So that means V over C equals the square root of 1 minus V squared over C squared, right? Because gamma is defined as 1 over all that. So 1 over gamma is just the square root. Square both sides, and you get V squared over C squared equals 1 minus V squared over C squared. Please do not try and cancel out the V's at this point. That's not going to be helpful. And it doesn't work, right? Actually, you add V squared over C squared to both sides. That gives you 2V squared over C squared equals 1. Therefore, V squared over C squared equals 1 over 2. So V equals 1 over root 2C.
Okay, yeah, it all makes sense now. It just...
I see what I did. I forgot the C. I forgot it was V over C, just wrote it as V, and that's it.
Alright.
Yeah, I wasn't even close.
Yeah, I just read it. C.
Yeah.
Yeah.
You were.
I thought it was in the same reference frame.
We were bamboozled.
Yeah.
Okay, a lot of you, look, I know you think that things were a silly invention of middle school teachers to come up with an excuse to take away points that you rightfully earned, right? But you just, a lot of you had answers that are nonsensical. They say things like C squared plus 1.
What?
C squared plus 1 makes no sense. Because C squared has units of meter squared over second squared. And 1 has no units. You cannot add those together, right? Why did that happen? Because you didn't keep track of your units. Probably you didn't do the light year properly, like I told you, and so you didn't get that factor of C, which will cause things to make more sense, right? So units are important, and you should pay attention to them. When the units are straightforward, as in say a gamma calculation, you don't need to worry about that. But I did tell you for light years, light seconds, and so forth. We'll see a lot more of those. You put the C in there so you can get the units to cancel right. Otherwise, it screws up your calculation, and you don't get the right answer. And things don't cancel out right.
Yeah, you're
Okay. So do watch out for that. Yeah, know what you do with order, but you screw up the units. Okay. So that was the quiz, right? Like I said, if you weren't happy with it, you should start thinking about next time I'm going to do this differently. And if you were happy with it, great, good for you. And I will leave it to you to decide what makes you happy and unhappy. Okay, do keep in mind that, so the way the redemption quiz works, when you get it, the redemption quiz allows you to redeem allows you to redeem all of your points up through level 2. Okay, because I think there's something to be said for getting things right the first time and also worth something. So you can redeem all your points up through level 2. Okay, you're like, well, what about my level 3? Well, we'll get it next time. You know.
darn.
The other thing is there is with this system there is a certain amount of oh, what if I didn't see my work this time? The fact is almost all that washes out. That's why we have so many tests. Then the different points, the randomness that is always intrinsic in all grading will tend to balance out over time.
You can get 75% from that problem?
Don't worry, I'm actually very careful with this.
Yeah.
This is the thing.
75%. This is 75%.
Oh, you're right. You can get 25%
You only just level 3, then you
of
have
20%. So, yeah.
I would improve, let me think.
So wait, we can,
I would
if we
improve it.
redo it,
It's different.
I would get
It's just
92.
It's just level 2, but we'll get to it when we get there.
totally work.
But it's different. It's not like I said, it's not what we do.
Okay, because 92 is, I think I can get like an 87, I think.
Wait, we have to come back.
Fine,
Yeah, so I was
fine.
taking pictures earlier.
Especially since your main problem is the exact
I know.
Same.
Look at this. Messed up the math, messed up the math, messed up the math, messed up the math.
Worse, Math and Science Academy.
Worse, you know what part of the math he
That's
messed up
where all
on?
of my
He didn't
lost
square
points
the velocity, he just took the square and wrote the 0.6.
Ethan, it's a lot easier to follow if you use scratch paper. 'cause I know-
Exactly. Yeah, I just didn't know we were allowed to ask for it.
Well, you could have just brought it out.
Oh, really? I didn't know we were allowed to use it. I've had teachers who don't.
It's something for next time.
Yeah.
Thank you.
Really sets it off.
Whoa. Do that? Is that everyone's? Better turn in, you get a 0. Everyone got better than 0.
Better turn it in and you get a 0.
Naturally. Okay. So, I want to talk a bit about Georgina and Valentino. Remember Georgina and Valentino? Yeah. I want to talk about Georgina and Valentino. And the problem that we mentioned earlier that seems like it should bother, it should be a problem. Okay? And the problem is that how is it possible that Valentino can see Georgina going slower? Right? So Valentino's looking at Georgina like the creepy stalker, he is, and when she's doing her jumping jacks, they're like real slow, right? But she is watching back because she is on the lookout for creepy stalkers, and she sees him doing jumping jacks slowly as well, right? How is it possible they both see each other slower? Why is it not symmetrical? Or rather, why is it too symmetrical? Depending how you look at it, right? How can they both see the other one going slower? Like, that doesn't make any sense. If everyone sees everyone else slower, then something seems wrong, right? Okay, let me see if we can quantify. Let me get a situation that demonstrates how something seems wrong. Here's one. Let's say Georgina and Valentino start at the same place, going at the same speed. Okay? And they're going to have a stupid race. Okay? This is the stupid race. The stupid race is they're going to race to see who can go 10 meters faster. Who can go 10 meters first?
What?
Yeah, they're going to race to see who can go 10 meters first.
In a spaceship?
In identical spaceships.
Okay.
It's a stupid race. It's totally. Okay? So she's going to go this way, he's going to go this way. Okay. Obviously, if you're standing at Earth watching them, what do you see?
them going away from each
They
other.
go 10 meters the same amount of time, right? They're going the same speed. Okay, now think about what Georgina sees. She's here, right? She, of course, to her, it's the 10 meters are moving over her, which is fine, right? Actually, there's a length contraction applied, right? That's fine. Okay, so she actually gets, she's going 10 over gamma, which is fine. That's okay. Valentino, because the whole thing is moving, Valentino's also going 10 over gamma, so it's still fine, right? That they're going the same distance still in her reference frame. That's what that matters. But, what's true about Valentino? Going a little slower, right? Oh, shoot, I did it wrong. Sorry, no. Let's not do a distance race. That's confusing. That's for a different problem. That's for a different demonstration. Let's do a even stupider race. Let's see who can go 10 seconds first.
That's not so
You go, you get in your spaceship, you drive, and then when your clock hits 10 seconds, you push the win button and you win. Unless someone else pushes it first. Okay? Alright, so hang on. There's all sorts of questions you could be asking at this point. Hang on. Okay,
How old are
here's the
Valentino
problem.
and Georgina?
Georgina's right here. Valentino's here.
They're either very
We know that Georgina's reference frame, her clock will take 10 seconds to go 10 seconds. But she's watching Valentino, and what will happen? His clock is going slower, right? Which means Georgina wins, right? So in this one, it's quite clear, Georgina wins. Okay. In this reference frame, this is Valentino's reference frame, Georgina's the one moving, right? Which means that whose clock is going slower? Georgina's clock is going slower, which means what?
Valentino
wins.
Well, wait, it's the same.
What happens if they
You're like, wait a minute. So who wins?
Neither of them.
Nobody wins
And
in
if
this
you're looking from
class.
the Earth, of course, it's
both
hot.
yeah.
Stupid race. Okay? But here's the thing. What seems like kind of a stupid race now becomes a little bit more confusing, right? Because it's not just like, duh, it's a tie. It's like, no, they actually have legitimate physical disagreements about who wins. So the thing to get out of this is not, oh, relativity must be wrong. No, it's not that simple, I'm afraid. Instead, you're going to be forced to throw out something else, which is that the winner can be uniquely determined. That is to say, the order of events that occur is relative. Order, because in Georgina's reference frame, she goes she pushes the button first, then Valentino does.
I get
In
that.
Valentino's reference frame,
It's
he pushes the
stupid.
button,
It's
then
so
Georgina
stupid.
does.
Does that mean time is relative?
Well, time has already been relative.
At the same time, okay? Order of events, therefore, can change in different reference frames. Right?
Yeah.
That is why, so you're like, so if you, the thing about the time dilation makes you uncomfortable, it should. But the solution to it is just to make you more uncomfortable. By now saying that different reference frames disagree on the order in which events take place. Now, that's not, that they don't disagree on the order of all events, because there are certain events that have to happen before other events, and the reference frames will agree on those. And people spend a long time trying to find a way around it, and they haven't. So, for example, the events, Emily enrolls at IMSA, Emily graduates from IMSA, have to happen in that order.
Yeah.
You can't graduate before you enroll, right? So all reference frames will actually agree on that. So there are events that are exceptions that will not do this. But some events can change orders in different reference frames. We will talk in more detail about exactly how to determine what that is. I can give you a general statement though that's a very important one, which is that events that are simultaneous in one reference frame are not simultaneous in any other reference frame.
Oh.
Okay? Events that are simultaneous in one reference frame are not simultaneous in any other reference frame. So in this case, you had the Earth's frame saw them winning simultaneously. All other reference frames will see them winning at different times. We'll see be one winning or the other. Yeah. If two events happen at the same time and the same place, then they're not two events, they're just one event. Because events are only distinguished by their
Time and
space
place.
time. So we assume they're separated in some, and there has to be something given with the coordinates. Then there wouldn't be any reference frames to shift to, because they'd be in the Earth's reference frame, right? So
Well, aren't they orbiting the Earth? So.
Okay, so my question is the Earth's reference frame sees them as both moving simultaneously?
Right.
If we're going to Gregorian, the one with the G,
Georgina.
reference frame, the other person, correct?
No, she
She went.
His clock's going slower, right? So it's going to take him longer to go 10 seconds.
Okay, because it's moving around her.
Because it's moving relative to her.
Yeah, okay.
It's not effective. Timothy was asking about what's the effect if it's moving this way. Well, the time dilation equation just has a v squared in it, so it only depends on speed. So it doesn't actually depend on direction. There are effects that depend on direction, but time dilation is not one of them. So even if they were going this way, you would still have the same problems. Oh, I see what you're saying. If you're moving this way, that's because they're in the same. They're at the same. Yes, you would still see that. When we do Lorentz transformations, we always put everything. Sorry, I'll talk about what that means. When we do transformations, we always put things moving in one direction, then in one axis, next direction. And so that's why I said that, because we just don't do reference frames in multiple dimensions. We shift our axes, so we don't have to worry about that. I see what you're saying, that's fair. But we don't usually deal with, this class we just shift one dimension, that's fine. Good. So, but how do you actually calculate that? Well, to do this, we need to go back, as I promised I would, to talk about space-time coordinates. Okay, here we go. Really what the question is you have two events, right? Remember what's this thing I just drew? The reference frame, right? That's what my reference frames look like. And you have two things that happen, right? So for example, Georgina pushing the win button, Valentino pushing the win button. Okay, two events. And then you have another reference frame, which, like I said, is always moving in the positive x direction by convention relative to the original reference frame. And that one, the same two events occur, but at different times, right? So, for example, you'll have this one will be defined by the 4 vector t, x, y, z. This one will be t prime, x prime, y prime, z prime. Okay? So we've seen this before. This is the same as Galilean relativity, right? But the only thing that's different now is the answer. So the answer is, so we have to figure out how these change. Okay, in the Galilean case, remember how easy it was? Because people were like, oh, well, of course the time doesn't change. Good one, guys. Right? So obviously the time has to change now. Right? We know different representation going to be in the time coordinate. Right? Furthermore, the x coordinate always changed, but now it's going to change differently because of length contraction. Right? Length contraction has got to be taken into account. So it's not going to be the same x coordinate. Good news is, for y and z being perpendicular, the y and z lengths directions, what do we know about those? They stay the same, so those don't change. So that's nice. Okay. But t and x definitely change. Okay. It is possible to work this out to derive this. I have found the derivation long and not that helpful. So I have decided to skip over the derivation. The most interesting derivation, I think, is the one that uses hyperbolic trick. But if you don't like your hyperbolic trig, then you might not like that derivation. There's another interesting one that uses the Pythagorean theorem in imaginary space, which is another fun one. And there's, I'm just not going to do that right now. Okay? You can look up the derivation yourself. This is well known. You can find it easily, but I'll just tell you the answer. It's extraordinarily important. It is all of relativity. Okay? And it looks like this.
I've seen this.
Now you knew there was going to be a gamma in here, right? No. Okay? These are extraordinarily important. You must have them committed to memory. People complain about it. Like, why do we have to memorize things? That's not real learning. That's baloney. Okay? Look, it's one thing to, look, let's say you're learning Chinese. It's one thing to have to look up the word for, like, you know, for ceramics. You know how to say ceramics. All right, I forgive you, right? But you shouldn't have to look up, like, if someone says, you know, ni hao, and you're like, ni hao, right? That's not right. That is not the right way to do these. Some things you must have in your memory, right? Some things you can look up, some things in your memory. This is your memory. This is the basic fundamental foundation of relativity. This here is actually all of relativity expressed in equation form. Okay? It is extremely important in a huge variety of fields. And because Einstein discovered these, they are called, they're called the Lorentz transformations. You're like, wait, what? Okay, what happened was Lorentz looked at Maxwell's equations and you know, remember Maxwell's equations from other videos? He says, you know, he worked out mathematically, if you do this as your transformation instead of Galileo, then Maxwell's equations don't change in reference frames. So he did that, but he's like, I don't know why you'd ever have used these guys, but like if you did it, you can do that, right? Then Einstein came along with the theory of relativity and re-derived the Lorentz transformations and said, hey, this is why Lorentz. Okay. Well, Lorentz had gotten them first with all the Lorentz transformations. Oh yeah. Yeah, this is all very close together here. Einstein called them Lorentz's transformations. So, Einstein was actually he was not perfect, but he was a pretty modest guy, all things considered. Being hailed as the greatest scientist who ever lived, or at least second greatest, like, you know, go to your head, he actually handled it pretty well, all things considered. Like, did you know that they offered him the presidency of Israel? Like, he would have been Israel's first president. Except he said, no.
It's like you're fine.
And honestly, that's not an easy thing to do, right? Like, I mean, honestly, how many of you saw an opportunity to be president? You'd be like, oh, okay, let's give it a shot. But can I do any worse, right? So, yeah. So, polarized transformations. So, like I said, you have to know them. You have to use them. Okay? You have to memorize them. This is like memorizing your name in Chinese or something if you're taking Chinese. You're not taking Chinese next lessons. Okay, but it's like learning your name. You just got to know it, right? How do you use them? Okay. Now is where all the stuff from last time starts getting applied. Because you can no longer use your physical intuition to get the right answer. Right? Instead, you have to rely on the mathematics to give you the right answer. So you're going to do the same steps that we did in Galilean relativity, but now you don't know what the answer is in advance. Right? You have to be good enough at the math that you can trust the math to give you the right outcome. So let's just take a real simple toy example. Something happens here, probably an explosion. So it's usually explosions. And another thing happens here, and let's say it happens, 3 light seconds away. I like light seconds, remember that? Okay, and plus 2 seconds, meaning 2 seconds after the first one. Okay. The first thing we need to do is to choose an origin. Remember that? So I don't give you an origin, you have to choose one. What would be a sensible place to put remember origin in time as well as space. What would be a sensible thing to use the origin? Good. Which one?
The first.
one that's not.
The one on the left. Yes. This would be a very sensible place to teach origin. You'll get the same answers no matter where you put it, but this would be a sensible place to put it because it makes things easier. It really does. You should always choose your origin as one of the events you care about. Makes your life easier. If you should have same answer no matter what, that'll make life easier. So if this is the origin, it has coordinate 0, 0, 0, 0. Right? Okay, what would be the origin of this? What would be the coordinate of this? 2 seconds, 3 light seconds, 0, 0. The last two are always going to be 0, 0 because we're going to keep it 2 dimension and 1 dimension. Okay. As I think you're beginning to understand, 1 dimension is enough to deal with. And the 2 dimensions don't matter much.
1 dimension.
Okay, so it's a lot of trick. So,
no, you don't think so?
So here we go. We're going to do little wrench transformations. So now I want to know, now I have another reference frame that's moving at velocity v relative to that, right? And I want to know what would this reference frame see for this one, okay? So I just take these and I plug these numbers in and I see what I get out, and that's my new coordinate, okay? So, for example, give me a specific velocity. 0.5c, all right, good. 0.5c, that'll work. For 0.5c, gamma is 2 over root 3. Did I get that right this time?
Yes.
Okay, okay, good. So, the velocity is 0.5c. So now I start plugging things into here, right? Now, for the first one, it comes out particularly 0. So this is the old t, x, y, z, right? And you want to find what is the new t prime, x prime, y prime, z prime. Okay, but this is pretty easy because look, if t and x are both 0, then what does t prime come out to?
0.
0, good. If t and x are both 0, this is going to be 0.
0 minus
right?
0.
And x prime?
0.
Also 0. And y and z prime?
0.
0, good. Okay, from this we learned an important lesson, which is why we do it. The origin always transforms to itself. Which we already knew, by the way. Remember I said all reference frames have
The same origin.
Remember that was our decided all reference frames have the same origin. So that's why you choose one that's the origins, then you don't have to do any work on that.
But we knew that.
This one here requires work, so let's do some work. T prime equals, okay, now we have gamma. Gamma we have is 2 over root 3. T is now 2 seconds minus v velocity is 1/2 c over c squared times x, which is 3 seconds. 3 light seconds. See what I did? All I did was substitute in this t and this x. And into the equation there, plus v and gamma, which I already had. Okay? Now, there's 2 factors of c up here and a c squared in the bottom. Those all cancel. That is usually what happens. And you have 2 over root 3 times 2 minus, what's left here? 2 minus 3/2 seconds. 2 minus 3/2 is 1/2. Good. Good. Still got it. 1/2 times 2 over 3 gives you 2 over 3 gives you 1 over root 3 seconds. So your new time coordinate in this reference frame is 1 over root 3 seconds. Which is nothing at all like 2 seconds. Okay? Then, let's see. Then your new x coordinate, x prime, is going to be 2 over root 3, and then you're just substituting it again. 3 light seconds minus v 1/2 c times 2 seconds. Okay? Which is 2 over root 3. This is 3 minus 1 light seconds. 3 minus 1 is 2. Good job. And so that gives you 4 over root 3 light seconds. Okay? And so that's the t prime, this is the x prime. So our overall 4 vector, just to put it together, is 1 over root 3 seconds, 4 over root 3 light seconds, 0, 0. That's how you do a Lorentz transformation. We did it with the Gaussian transformations, those were easy. Now it's a little more work. Micah.
How can the x coordinate be light seconds?
How can the x coordinate be in light seconds? Light seconds is the unit of distance.
Okay.
Yeah, no, I know. No, I don't want to confuse that. Don't worry about it.
So the original 4 vectors went through 0.
That's if you're stationary. That's stationary. It's choosing the origin, right? So it's not stationary. It's nothing stationary. It's just we choose one of the events as the origin. Oh, you mean this one? This is in some reference frame. I don't even say which reference frame. They don't have to be stationary. And then this works for any two reference frames. So when do you use Lorentz transformations? Look, they're a lot more complicated than time dilation length contraction, right? If you can use time dilation length contraction, you should, because they're easier. And you don't have to worry about signs and stuff like that. You don't have to set up a coordinate system, right? When do you use this? You guys kind of asked this before. When you don't have the proper time or the proper length that you need to solve the problem, which can happen. What if none of the reference frames even have the proper time? Well, the Lorentz transformations don't care. This works for any two reference frames. This is the general one, proper time and length. Time dilation length contraction are a special case. Okay? So these are the Lorentz transformations. Now, your homework, I'll give you some practice on it. That will, I hope, do it. The main thing is the sign of B. B can be positive or negative, just like before. Exact same rules as before. Watch out for it. Okay? One more thing. This homework has a chocolate chip cookie problem on it. Everyone who's taken my class knows the answer to the chocolate chip cookie problem. It's also online if you look for it. Don't look for it. It's not even graded. The chocolate chip cookie problem is very important. You should spend your time talking about it with your friends or enemies. Try and screw them up. Right? But like, the chocolate chip cookie problem is for you to think about, not for you to look up the answer. Anyone can look up an answer. But it's the thinking about it is where you learn about relativity. Okay? If the chocolate chip cookie problem seems very obvious, you're not thinking hard enough.
Done. What if we are thinking hard enough and it's just super easy?
Seems easy. Time it up. We're going
Right.
a little bit of a.
You're in a pickle.
Define right, because right is relative to worth.
And so let's say.
Thank you.